Hi, hello everyone. Welcome back to my YouTube channel. This is Parnika here. I'm pursuing my electronics and communication engineering at Sri Venkateshwara College of Engineering. Today, I'll be discussing about role of probability distribution in communication theory. That means I'm building a bridge between a mathematical concept and electronic concept. In order to know more about this, let's go deep dive into the subject. Let's go to our topic, role of probability distribution in communication theory. Introduction. In communication theory, probability distribution play a significant role in understanding the behavior of signals and noise during the transmission and reception of information. Probability distribution help to describe the likelihood of different events and outcomes, enabling the analysis and design of reliable communication systems. Here are some common probability distribution used in communication theory. Gaussian distribution, Bernoulli distribution, binomial distribution, Poisson distribution, exponential distribution, Rayleigh distribution, Riccian distribution. Coming to Gaussian distribution, or called as normal distribution. The Gaussian distribution is widely used to model the statistical behavior of noise in communication systems. It describes the random fluctuations in a continuous signal, such as thermal noise in electronic circuits or additive white Gaussian noise (AWGN) in wireless channels. The central limit theorem often justifies the use of Gaussian distributions in communication theory. This is the graph representing the Gaussian probability density function and the corresponding probability distribution function. Additive noise encountered in communication systems is characterized by the Gaussian probability density function, which is given as 1 by root 2 pi sigma exponential to the power of minus x square by 2 sigma square, having the limits minus infinity to plus infinity, where sigma square is the variance of the random variable x. The probability distribution function, which is shown in figure CP 5.2b, is given as f of x is equal to p of capital X is lesser or equal to small x. That is, the random variable is lesser or equal to small x, which is given as minus infinity to x f of x into v into dv, having the limits of minus infinity to plus infinity. Coming to Bernoulli distribution. The Bernoulli distribution is used to represent binary random variables where an event can have only two outcomes, that is, success or failure. In communication, Bernoulli distribution is applicable to binary modulation schemes like on off keying (OOK) and binary phase shift keying (BPSK). For example, we have a waveform, four waveforms. The first waveform is binary data sequence. The second one is bipolar NRZ sequence. Third is carrier wave. Fourth one is BPSK waveform. If you see the second waveform and the fourth waveform, we can see the similarity that if the square wave having the value of 1, here the sinusoidal value will also be 1 and will be positive. If the square wave is negative, the BPSK waveform will be also negative. What happens is when the carrier wave is generated and given when the input is given to the balance modulator or BPSK modulator, when the input is in the form of ones or zeros, there will be output in the form of pulse phase shift keying. Okay, uh, this is pulse phase shift keying. So this happens. The application in Bernoulli distribution is for binary modulation schemes like on-off keying. On is for one and zero is for off. Our next distribution is binomial distribution. It is an extension of Bernoulli distribution and is used when multiple Bernoulli trails independent events with two possible outcomes are performed. In communication theory, the binomial distribution can be used to model the number of bit errors in a digital communication system. What happens when we are speaking over a phone? The data sent by the sender, sometimes we will not be able to hear the same thing. So there will be an error with respect to bits. For example, see, this is data sent and this is data received. There is a change of everything is similar, 0, 0, 1, 0, 0. But here, for in for sending the value of 1, here the data will receive will be 0. So this is the error which can happen while transforming the data from one place to another place. Therefore, we can use binomial distribution to avoid such errors. There are other types of error also. Another error is burst error. Contiguous sequence of p bits in which first, last, and any number of intermediate bits are in error. Basically, in single bit errors, we'll have only one error. But here, if there are n number other than one error, if we have any other number of errors like 2 3 errors, it is called as burst errors. What is the reason behind this error is it is caused by impulse noise or by fading in wireless. Effect is greater at higher data rates. So basically, an error occurs when a bit is altered between transmission and reception. Let's go to the next distribution, that is Poisson distribution. It is used to describe the probability of a specific number of events occurring within a fixed interval when the events happen independently at a constant average rate. In communication, it finds application in modeling the arrival of messages or packets in a data communication system. This is an example for packet email. Header: sender's IP address, receiver's IP address, protocol packet number has 96 bits. Payload: data 896 bits. Trailer: data to show end of packet, error connection, 32 bits. Coming to exponential distribution, it is often employed to model the time between events in a Poisson process, where events occur randomly with a constant average rate. It is used in communication theory to model the inter-arrival times of messages or packets in data networks. This is the formula for exponential distribution formula. Rayleigh distribution. It is commonly used to model the amplitude of a signal when it undergoes random attenuation. Random attenuation is the unwanted noise signals, such as in wireless communication channels affected by multipath fading. Th- uh, this is really one wavelength which is touching its amplitude to value. This is really 0.5, which is touching its amplitude value to 1. This is really 1 whose amplitude is touching for 0.5, and the last is for really 2, where its amplitude is certainly between 0 to 0.5. And another graph which is plotted between the trace number as well as time. Bayesian distribution. It is used to describe the statistical behavior of signals in wireless communication systems when both a dominant line of sight component and scattered components exist. Basically, we have, if we are living in the house, okay, let's take this example. If we are living in the house, and if some our relative or friend is in car, and if we want to call them, first the signal has to pass to the tower and then to the car. It cannot directly pass to the car. So this happens without wire. This happens in wireless communication system when both the dominant line of sight component and scattered components exist. Totally from the house, the signals are scattered to tower and car. Correct. And another example for this is tower. I think these two are some uh, random buildings, mountain, and phone. If you're calling from the phone, it has to reach the tower, then come to house. It cannot directly come from mobile to building.
Let's have an overview. Gaussian distribution, Bernoulli distribution, binomial distribution, Poisson distribution, exponential distribution, Rayleigh distribution, and Bayesian distribution. Let's go to the conclusion now.
Communication engineers can perform various analyses such as evaluating the performance of modulation and coding schemes, estimating error rates, optimizing system parameters, and designing reliable and efficient communication systems. Probability theory is indispensable tool in understanding the uncertainties and a random process that affects communication systems, ensuring their successful operation in real world scenarios. If you like the video, please like, share, and subscribe. Thank you and have a great day.